Hi, in today's lesson, you'll be learning about the system of equations process. In the system of equations process, there are exactly two methods you have to know: the elimination method and the substitution method. First off, in this elimination method, you'll be given two equations, right? I'll just make up two equations right here that will be given to you in standard form. Standard form is like this, right? It's where you have two variables here, and these two variables will be equal to a constant on the right side or the left side. And we'll pick 2x plus minus y is equal to 10. Okay, and in this case here, we're pretty lucky because in this elimination method, what you're trying to do is that you're trying to manipulate these variables right here, or here, in order for that one of the variables can cancel out so that you'll be left with the one variable on the left side. And in this case, y minus y is equal to 0, right? And then 2x plus 2x is equal to 4x. But that's good because we already have one variable that already can cancel out. So when we add all the variables, right, we get 4x is equal to 20 plus 10 is equal to 30. Now we get x is equal to 15 over 2, right? So now, since we solved for a variable, we want to solve for the other variable, which is y. We can plug it, and we can plug it back, the answer, into this equation here, or we can plug back into this equation right here. So for now, we'll just pick this equation right here, and when we plug it back into that equation, we have to be careful because when we plug it back in for x, it's not just 15 over 2 plus y is equal to 20. It's 2 times, right, x is equal to 15 over 2. 2 times 15 over 2 plus y is equal to 20. Now, 15 over 2, which is just 7.5, 15 over 2 times 2, well, that's pretty easy. It's just 15, right? Because the 2's cancel out. And then we have plus y is equal to 20. Now, if we subtract 15 on both sides, then we get y is equal to 5. So now we solve for both variables. Now, the substitution method. Substitution. This is the second method you have to know. And in this method, you'll be given a variable and like what it's equal to, right? And sometimes you can have a constant over here, right? And then we'll just say is equal to 3x plus 20, right? And we have 2x, I'm just making up equations, plus 2y is equal to plus 20 is equal to 30. Okay, so then, right, in order to start off, right, for a substitution method, you just basically want to manipulate one equation so that you'll have one variable left alone, and then you can plug that variable into the other equation. So for example, right here, right, we can't really plug it back into this equation over here because y is not left alone. However, there's a fix. We can just divide both sides by 2. So then we'll have y is equal to 3x plus 3x over 2 plus 10. Right? And then we plug in y over here. 2 times 3x over 2 is just, let me just write this down here. Yeah, so 2 times 3x over 2, that's just 3x. 2 times 10 is equal to 20. I'll just put this in parentheses for organization purposes. Plus 20 is equal to 30. Now, we can't really do anything just yet because we still have to add the terms and then get all the variables on one side and get all the constants on the other side. So then we have 5x is equal to, right? So 3x plus 2x is equal to 5x, and then 20 plus 20 is equal to 40. So then, and then 30 minus 40 is equal to negative 10. Divide both sides by 5, and you get negative 2. So now, right, we plug back in negative 2 for one of the equations here. Now, we've already solved for y in a way, right? And I'm gonna take a moment, right, pause this video and just to see where you see how y is already solved. Okay, got your answer? Well, let's see if you're correct. So as you can see here, y is already solved right here, right? When we divided by 2, right, we actually unintentionally solved for y, so we can already plug x is equal to 2 equal to negative 2 back into this equation right here. So that's pretty convenient for us. So now we'll plug it back in, and we'll get y is equal to 3 times negative 2 over 2 plus 10, right? And this should just be equal to negative 3, right? The 2's cancel out, and you get negative 3 because of that negative constant, negative 1 constant, plus 10 is equal to is equal to 7. Yeah. So 7, and then y is equal to 7, and x is equal to negative 2 are our answers. So, however, there's actually an easy way to solve this equation here, and I intentionally said that you would have to divide by 2 on both sides, as you can see here. Yeah, as you can see right here, we have to divide. I just said we have to divide by 2 on both sides. However, if you see here, right, 2y here, right, 2y is here, and then 2y is right here also. However, since there are 2y's, right, in both equations, we can actually just replace 2y with 3x plus 20, so that the equation would be looking like this. And all I did, right, was just replace 2y with 2y. And we can do that since we'll have only one variable to work with. And that's exactly what happened right here. Sorry, I forgot a plus 20. Okay. Yeah, plus 20. And that's exactly what we did right here, right? If you simplify it, I'll just make it neater. Right? If you simplify this, or write it in a different way, you exactly get what we got here. So yeah, that's pretty neat. So as a recap, for elimination method, you want to cancel out, at least try to cancel out one variable, so that you end up solving for that variable, and then you want to plug that variable right back into one of the equations. For the substitution method, you want to plug one variable, right? You want to manipulate one side, and then other side. If it's already manipulated, then that's conveniently lucky for you. And then you want to plug that variable right into the variable in the other equation, right? And then you get 2x plus 3y, right? Just replace the variable with the variables on the other side, so that when you plug it back into the other equation, you only have one variable to work with. And yeah. However, for elimination method, right, we were pretty lucky here. So why don't we try to solve a more tedious elimination method problem? right? And for substitution method, we already kind of worked with the tedious problem, so we'll leave that alone for now. Okay, let me just erase this. Okay, so for another elimination method problem. Elimination. Sorry, 1 second. Okay, for another elimination method problem. Okay, so this time we'll have to actually manipulate one of the equations in order to solve for the variable. So for the okay. So in this case, the easiest thing to do, right, is that you want to pick out one variable. Okay, let's pick out one variable, right? So let's just pick, in this case, y. So in this case, 2 is bigger than -1, right? And somehow these two equations, 2 should somehow cancel out with -1. In order for that to happen, right, it has to be like 2 minus 2 is equal to 0. Right now we have 2 minus 1 is equal to 1 in this part right here. So in order for that to not happen, we have to actually do this, right? We have to multiply this equation here by 2. So that will become 2 minus 2 is equal to 0, right? Because it'll become 2 times -y, which then will be 2 times -2y, right, is equal to 0. So that's pretty much what elimination is all about. So I'll just rewrite this here again. So basically we have 4x, right? This is when we multiply everything by 2. Minus 2y is equal to 80, right? 40 times 2 is equal to 80. And then we have 3x plus 2y is equal to 20. Now, again, from the last example we did, add both equations. 7x is equal to 100, and then we have x is equal to 100 over 7. Now, when we plug this into one of the equations here, we'll just pick the bottom equation for no reason. So the bottom equation would then be 3 times, right? Be careful here. Make sure x gets plugged in properly. 3 times 100 over 7 plus 2y is equal to 20. Okay, so then 3 times 100 over 7 plus 2y is equal to 20. Okay, so now we've almost done, right? We're almost done. So it will just be this, 2y is equal to 20 minus 300 over 7. And then we want a common denominator, so then it will be 2y is equal to 140 minus 300 over 7. So then it would be 2y when we subtract both equations, negative 160 over 7, right? And then multiply both sides by 1/2, so 1/2, 1/2, and then our answer will be y is equal to negative 160 over 14. So we solve for both variables, and yeah, that was the substitution method and elimination method. Word problems for system equations are harder, but for now, these are the very basics of the system of equations process. Thank you, and I'll see you in the next video where we'll be doing word problems for the system of equations process.